Okay, as usual, we start with a free body diagram for this problem, and I've drawn on all the usual forces, the force of gravity acting vertically downwards, and I have resolved that into two components, one acting down the slope and one perpendicular to the slope. And then there is, of course, the normal force N acting perpendicular to the slope as well. Notice that there is a frictional force acting up the slope. This is the force which prevents the ball from sliding down the slope. It also produces a torque on the ball, causing the ball to roll. You may want to go back and review the section entitled "What part does friction play in rolling?" here. Carrying on with the problem. We need to look at the equations of motion, and we have first of all to consider the translational equations of motion. So, in the x direction, the translational equation of motion is mg sine phi, that's the component of gravity acting down the slope, minus the frictional force acting up the slope. That is on the left hand side of Newton's second law equation, and on the right hand side, as usual, we have the mass times the acceleration of the centre of mass. That's ACM subscript x, to indicate that it's in the x direction. Now we want the equation of motion perpendicular